Today we're going to be finishing our first section of statistics, section 1.1. This is the second video that goes with the first section of our class. Today we're going to be focusing on two-way tables, marginal distributions, conditional distributions, how we organize problems. By the end of this, we're going to know how to construct and interpret our two-way tables, as well as describe relationships between their categorical variables and how we organize our problems. So let's start with a sample problem to get us going. A sample of 200 children from the United Kingdom, ages 9 through 17, was selected from the Census at School website. The gender of each student was recorded along with which superpower they would most like to have. Here is that table. This is called a two-way table. Because it is showing two different sets of variables. It's showing superpower, preference, and then gender. So these are categorical in nature. And so the way we read this is it tells us how many fall into each category. So for instance, 30 people total wanted invisibility, whereas 17 females wanted invisibility and 13 males wanted invisibility. And we can see that there was a sample of 200 for 200 of the grand total down here. Make sure you fill in these margins, these totals, into your notes so you have them. Now, this is a two-way table. It describes two categorical variables. Like I said, the variables, if you're filling into your notes, are superpower and gender. Those are the two variables, superpower and gender. Now let's talk about what a marginal distribution is. It's a distribution of values that should vary among all individuals described by the table. It is a fraction or a decimal that can be converted to a percentage. So it's either the row or the column total divided by the table total. You're only looking at the margins of the table. That's why I said it's important to have those totals. So if you ever get a two-way table and the totals aren't there, you want to add them in. So, for example, say we wanted to find the marginal distribution of invisibility. We would take the invisibility total, which is 30, over the table total, which is 200, and you would get 0.15, and we convert that to 15%. Okay. You could make a bar graph, and if you wanted to display all of these marginal distributions. Okay. So on your notes, there's a place for you to do an example. Write the marginal distribution for gender. So if you want to pause right here, take a moment, maybe grab your calculator, and calculate the marginal distribution for each gender. So one for females and one for males. So you'll have 2 for gender. Now, while marginal distributions are great, they don't tell you how two variables relate to one another. Knowing that 15% of our population prefers invisibility doesn't really help us with knowing how that relates to gender. So this is where conditional distribution comes in. That describes the values of the variable among individuals who have a specific value of another variable. So you're still calculating it the same way, but now you're only focusing on a certain row or a certain column. So for instance, say we want to calculate the conditional distribution of superpowers for the females. Okay, so I'm focusing on the females for each superpower. So each female superpower would go on the top, and then the total number of females would go on the bottom. So this one, if I pick 20, I must be looking at the conditional distribution for freeze time. So what this 17.39% means, that tells me what percent of the females want that particular superpower. Okay? You can translate all of these into conditional distributions. Okay? You can also calculate the conditional distribution of gender for each superpower. So you could go the other way. So you wanted to know what percent of the people who wanted freeze time were female. That would be a different number. It would be the same numerator. 20 would still be on the top, but the denominator would be different. So take a moment and do that now for, well, actually it's right there. So say, let's see, where did this one come from? This tells me of the people who wanted to fly, what percent of them were female. So that's where they got 36 out of the 54. So conditional distribution can be a little bit confusing if it's not spelled out for you. It's hard to know which one you want to use. You have to ask yourself the question, do changes in one variable explain changes in the other? So we want to know, does gender influence the superpower, or do we think the superpower influences the gender? So depending on which one you think it is going to tell you how you calculate your conditional distribution, what you're focusing on. So when it comes to organizing our problems, there is a 4-step process. This is something that we're going to be using all year long. It's how we organize our statistical problems. It comes in 4 steps: state, plan, do, and conclude. If you want to pause this video for a second so you can copy down the missing parts in your notes, feel free to do so. We always want to know what we're trying to answer, right? What is the question you're trying to answer? I would hate for you to go through a problem and answer a question that's not being asked. Then you need to come up with a plan. What are you going to do? What techniques are needed? This will get more complicated as the year goes on. Then you're actually going to do what you said you were going to do in the plan. This, and for our purposes in the beginning, it's probably just going to stick with making some graphs and doing some basic calculations. Then comes a conclusion. You're going to give a practical conclusion in the setting of the real world. That's why I love statistics so much, guys. There are no problems that don't have real world context. Everything relates to something in the real world. So, based on our superpower gender example with these kids, we want to know, can we conclude that children differ in their superpower preference? Give appropriate evidence. This is a perfect time to use our 4-step process. So the first step, state. What do we want to know? We want to know, what is the relationship between gender and the answer to the question, what superpower would you prefer? That's what we want to know. What is that relationship? Is there an association there? So it's basically just restating the question in a way that makes more sense. Then we need to come up with some kind of plan. Well, it would be logical to suspect that gender might influence the child's opinion about superpowers, and not the other way around. So we'll compare the conditional distribution for females alone and then for males alone. So that means when you do your calculations, your denominator, when you're calculating for the distribution, will be the female total and then the male total for each superpower. All right, do is where we make a table, have a side-by-side bar graph. So where do these numbers come from? If you flip back to the other side of your notes, where did the 15 come from? Well, that would be the percent of females who preferred invisibility, 17 over whatever that total was. Obviously, these have been rounded. Your total should be 100 or about near it. You can always go more specific with your percentages, maybe 1 or 2 decimal places, but this one was rounded to whole numbers. And then, obviously, it's important to have a good visual aid. You learned that in the last video. So here's what we call a side-by-side bar graph. You could also do what's called a segmented bar graph. You can read more about that in your textbook. In fact, I encourage you to. In this section, they talk about segmented bar graphs. But you can also do a side-by-side one. And then you can come up with a conclusion. There's no set way to write a conclusion at this point. But you should use words where you're comparing and using the data that you have been given. So based on our sample data, it seems that females were much more likely to choose telepathy than males. We can see that here. Well, males are much more likely to choose super strength or freeze time than the females. Females were slightly more likely to choose flying and equally likely to choose invisibility. That's a perfectly fine conclusion, and we're giving evidence. The evidence comes from here. We wouldn't have written this conclusion without looking at the numbers and the graph. Now, something to note, association is what we're talking about here. Is there an association? Yes, there is an association between gender and superpower preference. If there wasn't, then everything would be the same. But association is not the same as correlation. They are two separate things. Do not use the word correlation if you're trying to mean association. Sometimes instead of association, we say not independent, aka dependent, but association will be the typical word we use. So for our association, values of one variable occur more or less frequently in combination with specific values of another. So like we said, there is an association between gender and superpower preference. Okay. I highly suggest you go in your textbook after listening to this video and reading over the example at the end of this first section and see how they talked more about these conditional distributions and how to use the four-step process and coming up with conclusions. We're going to do lots of practice with this. Writing is a very big thing in statistics. It's probably more writing than any other math class you'll have ever done. So keep that in mind. And that wraps up our very first section. And we will start our next section in our next video. Have a good one, guys.